So our next speaker, first talk in this this section, will be by Jordan Delus from the French National Library, which I can't pronounce in French. He can do that for me. He's going to give a talk entitled "Implementing a Storage Abstraction Service with iRODS."
Thank you. So in French, it's the Bibliothèque nationale de France, so BNF for short. Yep. Do you hear me? Okay, thank you. So today I will present you how we used iRODS to implement a storage abstraction service for our digital preservation system. Yes, and I will also present you how we migrated from recently from iRODS 3 to iRODS 4. Yes, this presentation will be more on the business side of the point of view, I think. Let's begin. Yes. So first, a little bit of context from the National Library of France. Some basic facts. So it's a public institution with roughly 2,200 agents and dozens of professions. We have approximately 1 million readers a year. And I put some figures that dates from December 31 from 2016. So we have approximately 15 million books, just as much posters and photographs, and roughly 2 million audiovisual material, and the list goes on and on. Some dates, some important dates. 1537, it's the year when the first law for legal deposit was created in France. So it stated that every book published on the territory should have a copy in the Royal Library at the time. And since then, the scope of this law was enlarged for engravings and maps, musical scores, photographs, and the list goes on and on until recently, in 2006, when we added legal deposit of the web. So the library has obligation to collect a representative part of the French web, as well as books. So preservation is obviously at the heart of BNF missions. So I translated for you the part of the law of 1994 that stated that the National Library had permission to collect, preserve, enrich, and make available in every field of knowledge the national heritage of which it has the guardianship. So it's quite a mission, actually. And in this context, we practice digital preservation as a direct continuation of our historical collections preservation. So we can consider two axes. First, digitization as a means to preserve analog documents, so paper, vinyl LPs, etc., that decay in time, and the digital avatar of this document can be used as a replacement for the original one. Second axis is for bound digital documents. So that concerns legal deposit of the web, and equally the deposit of audiovisual material that nowadays come in digital formats directly. The technical stakes are equally important. As time passes, loss of data is an ever more worrying risk. So historically, we practice digitization for the valorization of documents. So we digitize them in order to show them to people. But quite rapidly, we switched to preservation digitization, so that the digital avatar can actually be substituted for the analog one. which means it must withstand all the same level of expertise than of physical collection. Sorry. I recommend. I begin again. So yes, if the analog document decays, the digital one should replace it. With legal deposit of substitution, we receive digital documents in place of analog ones for practical reasons. So we don't have the original ones to digitize again if it were to be lost. And third, with born digital documents, the very notion of original is quite strange. So you see, as time passes, the level of risk on our digital data increases. On a second subject that is worrying is the sheer mass of documents. So you see, this chart is the number of documents in our digital preservation system since 2010, the year it was created, to December of last year. So I have some numbers. Last month we had 8 million, roughly 8.5 million packages, so you can understand them as digital documents, and for 3.5 petabytes of data. And that just concerns the part that is in our digital preservation system. But at the library, we have just as much data outside our digital preservation system that waits to be ingested. So roughly 7 petabytes, actually. So the response at the library was to create a digital preservation system. We call it SPAR, for Scalable Preservation and Archiving Repository. And it's built on the principles of OAIS that some of you may know. OAIS stands for Open Archival Information System. And it's a conceptual model that came from aerospace community because they were the first one to produce digital data, and quite naturally they were also the first one to lose some. So they were quite hungry for that, and they work on this subject a lot, and they produces OAIS. So SPAR, our digital preservation system, is made with the OAS concepts in mind. So it's an implementation of it. It's a tool of digital preservation at the BNF, and it runs since May 2010, and it was developed since 2007, I think. It's replicated on 2 sites, both for operations and storage aspect of it. One site in Paris and one site absolutely not in Paris for security reasons. Yes, we'll come to that later, in fact. I start with some notions that will be important for the presentation. First, the notion of information package. So we can think of it as a normalized way to present data, ensuring it has a clear control and it is addressable and findable in a system. And the first job of an OAS is to normalize the data that enters, and verify it conforms to quality standards, eventually transform it to conform to quality standards, augment it with different kinds of metadata, such as provenance, context, and a lot of other types of metadata, and finally index it and securely store it. So an OS does a lot of other things that I won't address today, but this leads us to our approach to manage this. An OAS is a complicated thing, and information packages are horrible objects that have lots of business implications, and it's advisable that our system administrators. Sorry. Yes. Okay, thank you. So it's advisable that our system administrators do not mess with this aspect of the problem. And equally, a computer system is a complicated thing, and storage technologies, as you know, can be horrible subjects with lots of technical implications. And it's equally advisable that our users, that are business side, do not deal with it. So the strategy we implemented was kind of divide and conquer one. So we divided the storage problematic in two parts. First, a storage module that understands business and is able to apply preservation policies. So the responsible of the collections for digital preservation must be able to express policies without considering technical problematics. And the second part is the Storage Abstraction Service that knows nothing about the business but reliably exposes offers of services on storage. So the stakes are, from one side, abstract the technical complexity for the storage module. So we expose these notions of storage unit and record. I come to this in a minute. And yes, so in order for the storage module to apply a policy based on for services. And the second aspect is to abstract the business complexity for the storage administrators. So they can migrate tapes and disks with no impact on information packages. So this separation of concern is really important for us. How we do that? So for the Storage Abstraction Service that we call SAS, we have four kind of objects. First, records and storage units, so that are abstract notions, and replica and storage elements that are concrete notions. The idea is that SAS exposes storage units when we put records and manages automatically the storage, replication, and retrieval aspect of things. And while it exposes storage units, it tells us how many elements it is composed and of what nature they are. So a storage element can be a tape or a disk. iRODS on its side has some very interesting model as well. First, I will go rapidly. The virtual file system with data object collections and replicas that are not concerned with the physical location of data objects. With resources and storage devices, these aspects are concerned with physical location of a data object, and the zones and the server are concerned with system deployment. So this separation of concerns is quite interesting for us because it allows us to separately manage data and container aspects of the storage abstraction services. For implementation, sorry. For implementation, until recently we used iRODS 3. We have some custom-made rules. The classic crude ones: create, read, update, and delete ones. Which we added audit verb to verify and repair integrity of a record. And we had homemade hierarchical resources. So our notion of storage units as storage elements were homemade. And we had actually the first storage elements accumulate the role of storage unit as well. So for one storage unit, you had, if you had 3 storage elements, you had 3 resources in iRODS. Nowadays, with iRODS 4, we make use of the native hierarchical resources. So a storage unit is a coordinating resource of type replication. And our storage element is a combination of a coordinating resource pass-through and a storage resource, which are Unix file system ones. So nowadays, one capsule is actually this kind of tree. So it's more simple to manage. Yes, it's quite a good addition to iRODS 4. Yes, it will be short for the migration slide. We don't. So the migration from iRODS 4 to iRODS 3 to iRODS 4. A bit of context. We had 16 million entries in the table R data main, and approximately 24 million in our meta main for the metadata. Our backend database is PostgreSQL, and we started development with iRODS 4.1.7, and actually we finished it with iRODS 4.1.10, and then upgraded to 11. The steps were to first upgrade the iCatch schema from version 2 to version 4, really standard. We renamed some of our metadata, and we migrated then our SAS implementation to version 4. For the first part, because the updates were really huge, we needed to drop index and perform full vacuum. Otherwise, it would be too long. And so we drop index, apply the upgrade, and perform vacuum and recreate index. To rename some of attributes, we do the same thing actually. So we dropped index, updated metadata, recreated index. For migration of our old storage unit, thank you, to storage elements, well, that's when it gets complicated. I think I won't have the time to, yeah. We had to make it unit by unit, actually. But we did homebrew SQL, actually. Yes, I won't have time to finish this. So, what I wanted to say in the conclusion is that iRODS, we use iRODS in a quite simple way compared to some of you that I saw these 2 days. Yeah. Our Storage Abstraction Service allows us to enforce our daily operations without stopping. iRODS is a central element, although we use it in a quite simple way. And yeah, migration from iRODS 3 to iRODS 4 was unsurprisingly not easy. We had a lot of problems that some of the people had talked about last year, I think. And yeah, now we are ready to investigate an upgrade to iRODS 4.2. And we are particularly interested what it has to offer in terms of rebalance. Yeah, thank you. Have questions? So, thank you. Sorry, I was a bit long.
Any questions? I would like to know a little bit about what was hard about the 3 to 4. Do you know?
Sorry?
Can you say a little bit more about what was hard about going from 3 to 4? I mean, I know it has to be manual. There was no way to do it.
Yes, there was
automatically.
A lot of manual tasks, and some problem we had were not actually on the migration part, but on the new implementation. We wanted to use PEPs a lot more and get rid of our custom rules. But we weren't able to find everything that we needed in terms of documentation, and also also in terms of context in the PEPs. So we didn't have every variable we needed to perform our tasks. So we stayed with the rules, and we scratched our head with that quite a long time actually.
Fair enough. Question? We have one? How long did it take to actually do the migration? Is that the question?
In what aspect? So we worked on it for a year, but the actual migration takes roughly 8 hours, I think. 6? Yeah.
Yeah. So it was a full table scan of our data main because of the, why did we do that? Everything. Yeah. Everything changed. Yeah, the move to 3 to 4 was big. I'm thinking of the move from 4.1 to 4.2. But
yeah, we hope so.
Yes. Anything else? Excellent. Thank you.
Thanks a lot.